Good morning. So our next unit that we are going to be targeting is the atoms in the periodic table. The first thing we're going to look at is how our knowledge or understanding of what an atom is has changed over time. So that includes our atomic theory and understanding that all matter is made up of these basic building blocks called atoms. So again, what you guys are going to be doing is trying to describe that an atom is our smallest unit of an element, and those are made up of subatomic particles, and hopefully some of this should sound familiar. Your subatomic particles include your protons, your neutrons, and your electrons. So you should hopefully have heard those ones before. Remember, protons have the positive charge, neutrons are neutral, and then electrons are negative. All right, so as we get going, hopefully you guys can start pulling back in that prior knowledge that you had, and we can keep expanding upon it. All right, so just a reminder, again, atoms make up all matter. Now remember, we said some things are not matter, and that would be types of energy. So heat, sound, light, those are not composed of certain atoms. Whereas everything else that you can see, even the things you can't see, like the air you are breathing, are made up of atoms. And those atoms are arranged on our periodic table. Remember, we have 118 different elements, which means we have 118 different atoms. Each atom is different. So for example, an atom of hydrogen is not always identical to other hydrogen atoms. And we'll talk about that. We'll talk about ions, we'll talk about isotopes. In a similar way, no matter what, an atom of hydrogen will never be the same as an atom of helium. Okay? So remember, 118 different elements, which means there's 118 different atoms. So again, atoms are building blocks of all matter. They are too small to see without very, very powerful microscopes. With the atomic structure, there's a couple things hopefully you remember. Within the nucleus, we have our protons and our neutrons. So right here at the very, very dense center, we have our protons and neutrons. Outside around it in our electron cloud are our electrons, and they are speeding around, okay, constantly in motion. So those are two basic components of every atom. Now again, remember, P proton, P positive. That is located in the nucleus. Careful though, a lot of people say P proton, P positive, N neutron, N negative. Ah man, doesn't work. You see that? So you gotta be really, really careful. And remember that if it is neutrons, it is neutral. So if you're neutral, that means it has no charge. Electrons have a negative charge. Now, hopefully you guys remember, if I consider the mass, a proton has a mass of 1 AMU, a neutron has a mass of 1 AMU, and we say that electrons have a mass of 0. So you can look and see that our nucleus as a whole will have all the mass, and it will be positively charged. Outside the nucleus, in that electron cloud, we will have a negative charge because there's only the electrons out there. All right, so here's again a nice little visual for you. Outside, again, those electrons orbiting around the nucleus, constantly in motion. Within the nucleus, we have those protons and neutrons. All right, so how the atomic theory has changed over time kind of changes with our understanding and being able to identify the different particles. So when we first start out, Democritus first thought that everything must be made of some type of building block, and he called that building block an atom. So the reason why he thought that is because if you look at a building is made up of many bricks. All those bricks together make the building. One brick alone will not. So when he starts looking at all these complex different types of matter, like himself, plants, birds, he started saying, okay, well, how do we have this matter? And so that idea that everything's made up of a small atom started to evolve. We then started to see a change in what the actual atom looked like, from just being a sphere of mass to then having a plum pudding atom, if you look there, where we kind of just have the negatives and the positive just kind of sprinkled throughout. So you can see here sort of how it has changed over time, the shape of our atom, understanding that those electrons should be in orbitals with our Bohr model, to now understanding that there are electron clouds that are actually taken up in 3D dimensional space, rather than it being more of a planar type system with the Bohr model. All right, so since we can't see atoms, we tend to use those models to teach and learn about them, okay? And so how they've changed is what we are going to be looking at. Remember, as we gain more and more information through research and better understanding new technologies helping us be able to visualize these different particles, we're able to change and adapt our atomic theory. So John Dalton was the very first one who came out and came up with his atomic theory, and he basically said all matter is made of atoms. Well, we know today that is still true. He knew that atoms were too small to see. He said they were indivisible and indestructible, so you could not split them, can't cut them, can't nothing. He said all atoms of a given element are identical. So part of his atomic theory is correct, part of it is not correct. So the first part, all matter is made up of atoms, that is totally 100% true. He said that they are indivisible, which means we can't divide them. Well, think of like fission and a uranium bomb trying to split the atom, shooting a neutron at the atom in order to cause that fission process to take place. We can split them. And then he said that they were all identical. Well, not necessarily, because some hydrogen atoms have 0 neutrons, some have 1, and some have 2. So they're not necessarily 100% identical. Our next transition was with J.J. Thomson. He was the first one to actually discover the negative electron, and he predicted that there must be a positive particle in order to hold it in place, because he knew that opposites attract. So if I have a negative particle, then I must also have a positive particle. So if you look at his model, you can see it's more like a plum pudding, where you kind of just have the different particles sprinkled throughout. So there's positive sprinkled throughout, negative sprinkled throughout in that model. Whereas now with Ernest Rutherford, he was the one that actually discovered the nucleus, and he named that positive region protons. He considered that the electrons had to be scattered in empty space around the nucleus. So again, he kind of just said, okay, well, the electrons are out and around that nucleus, inside is positive. Now, if you notice something about his model, he's still missing those neutrons. He's still missing those neutrons. Now, finally, James Chadwick comes in, and he does discover the neutron and realizes that there is no charge with that neutron. So we added to our model, and we see the addition of those neutral particles. Electrons still outside around the nucleus. All right, finally we get to Niels Bohr. Niels Bohr decided that, okay, we do have that nucleus is positively charged because I have protons and then I have neutrons. Neutrons have no charge. And then outside around, kind of orbiting like our Earth does the sun, we have our electrons. So those electrons are actually locked into those orbitals, and they kind of just orbit around and around and around. All right, so many scientists, when we come and start looking at now our modern atomic theory, we know that electrons don't orbit like a nice little planetary orbit, okay? They actually move at a very, very high speed in an electron cloud around the actual nucleus. Not only that, we know that those electron clouds are three-dimensional, which means there are different shapes to the electron clouds, there are different regions. When you start taking those higher level chemistry classes, you'll actually get into that a little bit more. But when we look back at kind of what has been transpiring over history, they did a pretty good job. They knew that all matter was made up of something smaller, and they called it an atom. They were able to identify the protons and neutrons and the electrons. So now when we get to modern day, we can look at, okay, now that I have a basic understanding of the atom, are there other things that make up matter? So is there something smaller than protons, neutrons, and electrons? And this is probably where you've heard the word like quarks or string theory starting to come in. So our knowledge on the atom is not done. There's still a lot of research that's being done. So this model that we're looking at today may change come 20 years by the time your kids are actually going to high school. So, all right, guys, that is it for today. Nice job.